Alright, I hit the button. Let's see what happens and such. Yeah. So, live chat, and then pop out the chat, and then we'll get on to what we're going to get on to. So, I thought I would, I saw this video, and I played part of it, and I said, yeah, okay, let's do this one, because, it's kind of ironic and funny, and, it's just whatever, the same old crapola. But anyway, this is this guy Dialect. Okay, he's got a nice little soft personality and does his little physics explanations. Now, if I'm remembering correct, he had some video with a bunch of animations and monkey and apple in it, and his theory. The theory he argued for is that somehow we're accelerating upward on Earth. When I would argue that the whole reason there is gravity is because the first acceleration is in, okay? And all the Earth does is push you back. And you never really can undo the first act, which is the pushing in part. The Earth can just restore you back to where you were, and then the gravity pushes you in again. So that one just keeps winning. And that's why there's gravity, is frankly because there's a bunch of matter being pushed towards the center of the Earth, and all of that uses energy. That acceleration isn't for free, and so there's less energy coming out of the Earth than went into the Earth because you're using a bunch of energy to move things into the Earth. So I can argue that simple explanation works. But anyway, so this is an extension of that subject, sort of, in the sense it has to do with space and time. And so we're going back to Galileo and Newton, Descartes again, and that, they gave you, a great foundation, frankly, and you really didn't need to make this big giant mess out of everything. So the whole idea of relativity can be understood in the simple Galilean version of it, which is you're in three-dimensional space, and you can have, you're here and something else is here, and you can share a feature. You can both be going this way. And so, yes, relative to each other, okay, you can ignore the part that you're both going this way. It just doesn't matter. And you can interact with each other, and that precondition that you both have will be kind of ignored. You won't pay much attention to it because it doesn't change anything except it's some underlying fact, and it just doesn't matter. I mean, you could interact with somebody who had exactly the same number of hairs on their head. You can know it or you can not know it. It doesn't really matter, right? It doesn't mean anything. It's a similarity or a commonality that doesn't change anything else that's going on. So it's sort of irrelevant. So yes, you can have a bunch of common conditions, common circumstances, and so you can understand that you have a condition relative to each other, and you have a condition relative to the whole universe, the absolute universe. And so you don't have to break three dimensions, and you don't have to break any of this stuff to sit there and understand relativity is just a circumstance. And it doesn't mean much. It doesn't do anything more than that, okay? It doesn't bend space or time. All right, so let's play his video, and then I can react to every single sentence and just point out how it's all a bunch of crap. So he's arguing against the other crap purveyors, and he's just supporting his own version of crap. There's the real argument here, and he's pretending he's doing something better than they're doing, when no, he isn't. He's just selling his personal favorite.
Almost every approach to teaching relativity begins the same.
Okay, we should fix this volume as best we can anyway. I mean, the system's volume should be... it should be recording, okay? Let's just I'll look at it and see if it's doing what it's supposed to be doing. Yeah.
You get a set of pseudo-mystical sounding statements.
Too loud, maybe.
Time and space are relative. The universe has a speed limit. There is no ether. Reality is a four-dimensional entity exhibiting curvature.
Right, so you don't need any of this stuff, okay? So if you do, you can just accept there's relative conditions. You could be in relative conditions. and that the space you're traveling through, again, is just three-dimensional space, and time is just a function. That it does just go in one direction, and it just has to do with it takes time for events to happen. And it's just a fact. Things don't happen instantaneously. So nothing goes from here to there instantaneously. Therefore, the universe takes time for things to happen because everything's moving slower than immediately. Now, instantaneous. So all events don't happen in the same time, in the same moment. And the moment exists because of that very fact that things just aren't happening the same time. So that's it. But it doesn't do anything else. You don't have to believe it does anything else. You don't have to believe time is anything else. That you can change it in some way, or distort it, or save it, or preserve it, or move through it in some other way, but by the same laws that all the other material things have to move through it. There's no good evidence that there's any such thing as any space-time curvature. All there's good evidence for is there's some sort of pressure pushing things towards the sort of center of objects, in the general direction of.
And so on.
All right, time and space are relative. So again, time is just a function. Space is three dimensions of nothing that things move in. And it takes time for them to move in the space. Okay? Nothing travels faster than light. It's not a law. It's just this argument that the smallest stuff, I would argue, the smallest, lightest stuff can go that speed. And all the other stuff is heavier and therefore can't go that speed. Okay. Ether does not exist. Well, you don't need it. So it's a superfluous, fun idea. You could say gremlins don't exist because, well, you don't need to believe in them. There's no real hard evidence for them, so don't believe in them. Seems the logical thing to do. But whether it exists or not, it certainly doesn't exist in any... I mean, the evidence, I think, sort of could prove that it doesn't exist in any jello way, like the ether's made out of matter way. Alright, reality is a 4D structure. Now, there's no good reason to believe any of these 4D crap, okay? So the three dimensions are well established. This way, right? And this way. And the key ingredient the dimensions all have is they have a thing in common, and that is they're always 90 degrees to each other. The space has this property. The rule is if you're going to say there's a dimension, it really is obligated to be at right angles to the other three. And there's no way to mathematically make that object. So a fourth dimension will never be a real spatial dimension. It won't obey the basic rules of what the word should mean. It's not the same thing. It's just bad. It's just breaking a vocabulary to call it a dimension. You have to call it something else. And I think the logical word to use is function. It's just a function. Time is a function. It's not a dimension. It's not a place. It's not any kind of structure. It's not a universe. It's not...
Then you are told certain empirical experiments prove the math.
Alright, so this whole stupid experiment crap, right, where these huge exaggerations about what the experiment means. So all of the experiments, they say, continue to prove relativity, are not proving anything except that speed affects how radioactive particles decay. So they really haven't proven that anything called real time, that is, the mechanical processes in the whole universe somehow change because you decide to go really fast. All it's really saying is that certain mechanical processes don't happen the same way when you move a clock very fast. So some machine we make to tick off a process, a physical process like the decay of an atom, and we already know we can affect decay. So if we want to change, we can just give something a number. We can say, okay, uranium decays every 10,000 years. It takes 10,000 years on average, and so that's the average decay happening event. 10,000 of them once a year, or whatever the thing would be. Okay. So if you have 10,000 of them once a year, one of them will decay. Whatever it's just a mathematical description of a mechanical process. And the fact is that I shove a bunch of those atoms together next to each other, they'll decay much faster. So I'm changing their elemental property by just doing something as simple as shoving them next to each other. And so should we be surprised that if I gave them velocity or changed some other property, that would also change the decay rate? I don't think there's any reason to think that's surprising. So why would I think that just because I make something go fast, I've changed time, when all I've done is broken the clock? I mean, it's the simple, reasonable explanation, and all of this shit happens. And the whole Michelson-Morley thing is more about ethers than it is about any kind of relativity argument. So I don't even know why that's being thrown in here. It really doesn't have a damn thing to do with it.
And the math in turn proves
and the Lorentz transformation is just coming up with a gimmick to get rid of your unintended infinity. So it's just this idea, well, I'll divide it by the speed of light. Nothing goes faster than the speed of light, so I'll end up with a decimal number, and I'll just keep multiplying everything by that decimal number, and then I'll be assured that I'll never end up with an infinity. So what? That doesn't mean anything. You contrive a way to escape an infinity. Oh, okay. How does that have something to do with reality? We're supposed to assume that nature contrived a pile of crap to evade an infinity? I don't think nature bothers trying to evade affinities.
Philosophy. But does a mathematical formalism ever necessarily
So this is all nice little jiggery-riggery. Let's flip around, do all this crap, just throw a face in here now and then and say we've done something. When they haven't done anything. So a lot of this problem, look, Einstein came up with this relativity thing because of his interpretation of 1/2 mv squared. And the whole idea that somehow he could accept that the squaring of velocity makes sense somehow.
Necessitate a single interpretation? Certainly, this isn't the case with quantum mechanics.
So I don't know why he's saying that this relativity thing is about that simple gimmick of Lorentz's. So I don't know why that's an association. So he's doing this as a nice little image of the Schrodinger cat kind of thing. It's kind of sympathetic, frankly. So he's arguing that it's okay to have a bunch of wacky theories about how quantum mechanics works. Now, all of them don't work. That's the key feature. None of them are tested, and no one points out that, well, Copenhagen really doesn't get the right answer. And certainly that stupid Bohm thing, pilot wave thing, that doesn't answer the question correctly either. It doesn't analyze the double slit correctly. It doesn't get the right pattern. So I mean, it's so bullshit on its face because none of these theories actually work. They just say they do. All right, they don't prove that they do.
Which sports a rich diversity of viable and competing philosophies.
So, okay, Copenhagen doesn't work. That's why there's these other alternatives. It's because it doesn't actually work. Okay, multiverse is so silly, it's just like, well, okay, why don't you just invent the Invisible Man? Okay, why don't you just call it Invisible Maniverse? Because it's just such a pile of made-up crap that I'll evade all the problems created by this stupid entanglement, de-entanglement crap, because I'll just create an infinite number of universes that are constantly created every time a photon moves somewhere. Every time it hits an atom in the atmosphere, every time it goes through a transparency, every single, it's supposed to be bent by gravity by their theory. If it's bent by gravity, well, every time it's bending by gravity, it's creating a new universe. I mean, too silly. Again, pilot wave doesn't work. Okay, it's going all the way back to Thomas Young's drawing and saying, well, that's an accurate drawing, so we'll duplicate that drawing, when that drawing didn't produce the double slit pattern. Young's analysis of the double slit pattern produced the single slit pattern. It's the wrong pattern. Okay, and then whatever this Bayesianism, Darwinism, quantum Darwinism, who knows what the fuck that is. Shit.
Of course, this might lead you to
Relative QM, well, no, relational QM, who the fuck knows what that is, and then information theory, yeah, that's one of my favorite silly ideas. That's up there with the multiverse, that somehow all the little actions in the universe are somehow a piece of information, and they're all stored in some sort of hologram around black holes, and blah, blah, blah. I mean, it's just such a fucking pile of shit. All right, so he says relativity just has Lorentzianism and Einsteinianism, which, whatever.
question, are there other interpretations of relativity out there? And if so,
The simple question is there anything that really requires you to believe that there isn't 3 dimensions of space, and that things are functioning in those 3 dimensions, that there is in fact an absolute universe, that everything is in some quadrant, some place in the 3 dimensions all the time, like every unit of time they are moving through the universe or in some other new place, and that all the relativity is just coincidental, in the sense it's just incidental, a byproduct of your absolute conditions, and the fact that some things have to move with each other. So all the little atoms of this pen, most all of them, right, tiny percentage right now are in flux. They haven't decided whether they're the pen or they're the atmosphere, so some of them are a little bit confused, but most all of them are going to be obliged to move in the same direction because they have connecting forces and, you know, strings that tie to each other, so to speak, and they're all going to go in the same way. And somehow I should be, oh, that's amazing, you know, they have a relative condition. No, it's not amazing. Lots of things have relative conditions because they're sitting on a gigantic planet, and the gigantic planet's so much bigger than they are, it's going to essentially tell the thing where it's going. Right? It's riding in a bus. No big surprise that it's going somewhere.
so should we be teaching them this?
So this whole teaching thing is sort of annoying too. So yeah, a lot of people are out there taking advantage of the fact that they can dupe young people into believing all kinds of wacky shit, and young people have an incentive to learn it so they can make a living and blah 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 and all this crap. And so it's not just for the sake of the science, okay? It's for some purpose of selling an idea, and selling your idea as the one people think is right, and therefore you get the views, and therefore you can make the money. And it's really not some proper analysis of the speculations that are out there, and measuring them in some sort of fair and disciplined way with real evidence as part of the trial. I mean, you're sitting here at trial, you're trying to say yes or no to something, and are we having fair trials to make those decisions? And I'm saying we never put bent space on, there's never been a fair trial, you know, where you decide the truth by measuring all the pieces of evidence. Again, all of the evidence is just exaggerations about what experiments actually prove. So when the clock you have on Earth, and frankly it's the one on Earth that's moving too fast, okay, it's the one being time dilated because of its added velocity, ironically, because it's the one in the heavier gravity being bounced in the gravity. And so, yeah, even that argument, right? So let's go to trial and let's put the idea that we are being bounced in gravity. That is, we're constantly being pushed into it. We don't feel that because it's gravity. You can't feel gravity because it moves all your bits at the same acceleration. So there's no sense of, ooh, part of me is moving faster than another part. And clearly when the Earth pushes you back, it does it in a chemical way, so you can feel it. So you feel the Earth pushing you back, and you don't feel the gravity pushing you in. And so you have this illusion, okay, that there's only one force, when no, there's two actions, and you are essentially moving in, and then you're pushed back, and then you move in, and then you're pushed back. So you're doing a lot of moving when you're going on the straight line around the Earth's rotation. So as the Earth rotates you and moves you, you're not just moving that simple little line, you're moving a jiggling line. So I've used the analogy of the basketball player versus the basketball. The basketball player is going 5 miles an hour. The ball is going 50 miles an hour. You know, that kind of thing. Because it's traveling a lot more distance. Because it's going up and down the whole time.
This is dialect with the...
Whatever all that creepy writing is, you make it look like Latin, you know, or whatever. Blah, blah,
real
blah.
reason you don't understand relativity.
I really can't hear this, so maybe it'll be too loud for you, but I need a little more volume. Maybe I take a little bit off of his volume and see if that works.
Last year, we successfully debunked a major myth of general relativity.
So, you know, this is sort of, you know, a myth of, you know, you sold a new myth with, you know, your argument. Okay, so he has this idea that somehow the net acceleration is out when the net acceleration is clearly into the Earth. Your more energy is going in than is coming out. That's why there is gravity.
Which went along the lines of time dilation causes gravity. At the time, this idea appeared to us to be so ludicrously in contradiction with the basic tenets of relativity.
So whatever the basic tenets of relativity are. So this is a, you know, he's already telling us it's a, you know, his deism. You know, we have to accept all of this pile of crap as having some sort of credibility as a proven theory when no, it isn't anything near that. And all you have are certain little points, little pieces of evidence indicating an ambiguous, making ambiguous statements about reality. Again, it's really easy just to say you're breaking clocks, you're breaking mechanical time-telling devices. You're not doing anything else. And in a way you could say, you know, like say if you were to say a person had the perception, okay, you know, that somehow they were being time dilated or moved into the future. They can't perceive it as an actual process because the fact is they're basically just being frozen and then woken up in the future. So that's the only kind of time travel that could possibly be mechanically, is that if you're going to actually do what this thing says and create this circumstance where you're time dilated, all it's really going to mean is that every mechanical process inside of you is somehow moving incredibly slowly. Okay, and that's it. That somehow your physical circumstance has changed and you've frozen while the rest of the universe gets to keep going the same speed it was going before and the same temperature. And that your temperature, your heartbeat has gotten, you know, you only have one heartbeat per year because you're moving the speed of light or near the speed of light. And it's just not true. There's no reason to believe that actually happens.
That we assumed it had to be a product solely of the YouTube sphere. But after...
It's not that just the YouTube sphere, it's physics sphere. So I could go to, you know, instead of just showing these, whatever, pop physics channels, you could show lectures by Stanford. You know, what's his name? Well, whatever. You know, the Feynman lectures. There's lots of other pieces of information that aren't just, let's put on a documentary show. Let's do this, whatever it is, scientainment stuff. And it's still selling crap. I mean, you can read a book. I did it on Einstein, and, you know, it's still got crap in it. You know, I mean, it's just, you know, stuff said without much behind it, except this is the story I've accepted.
Publishing our video, we discovered to our surprise that the misconception extended far beyond YouTube. appearing in textbooks and even quoted by renowned physicists.
Well, there you go. But whatever he's saying, there's a misconception. I'd say the whole thing is made out of misconception. The whole thing is made out of fake arguments, that somehow there's this volume of evidence indicating we must believe, when the evidence is as simple as, yeah, when you move a clock really fast, it doesn't mechanically work the same way because the pieces, the atoms, don't function the same way when you give them an absolute acceleration that high. The little bits don't move the same speed between them. The pressure between the atoms, the charge, the different things change, and it therefore breaks the clock. It isn't going to do mechanically the same thing anymore because you've distorted its ability to function because you've changed the physics. I mean, you've got the sandblaster turned up too high, so to speak.
This, of course, got us wondering, how could such brilliant people get their own theory so incredibly wrong? Well, the answer is because relativity, very much like quantum mechanics, is extremely confusing, and it's doubtful anyone truly understands it.
I mean, that's just such a silly thing to say, because it's all just about how you understand it. And so you can understand something very complicated by understanding it in pieces, like this image even, where you can, break it into pieces, and you have the pieces in the right order, and you can see the forest through the trees, and you can see the tree through the forest. You just have to have enough familiarity with it to be able to do that. But it's doable, so that's just kind of bullshit that this has to be confusing when, no, it doesn't. That has to have all these complex mathematical elements when it doesn't. Okay, it's just, you're just talking about what is space. Is it 3 dimensions of space, or is there some other frankly nonsense where it doesn't matter what position things are in, or that somehow their position is somehow they're sharing a duality with every past event and with every future event, that somehow all the things in this place in space are in this place in space right now, and it's not just this pen, but all kinds of the past and all kinds of the future are somehow occupying this piece of space. I mean, ridiculous notions that can be just out of hand said, well, until you provide some sort of evidence that that crap is true, there's just no good reason to believe it. It's not confusing. It's relativity has as many wacky interpretations as quantum mechanics. I mean, as soon as you start talking about it, you start breaking all kinds of, you start having to ask the question, well, if you're going to say time is a dimension, well, then is everything occupying that dimension? I mean, even though I know the atoms that make me up were the same atoms that, say, a brontosaurus was, had in it, or all these other, millions of years ago, there was something else was using that atom. So how can that atom be in all these different time places when, no, I'm using it right now? And where it was before was a different place. I mean, the brontosaurus wasn't where I'm sitting.
Of course, with quantum mechanics, this fact, being openly acknowledged, has led to a rich and intriguing field of diversified interpretation.
I mean, what a joke. I mean, to say a rich and diversified field of confusing, mishy-mushy bullshit. Silly drawings, moronic equations, just a bunch of many worlds. I mean, come on. Any of this isn't confusing and stupid and retarded? And again, it doesn't work, which is even more outstanding, is it doesn't actually make any sense. The whole entanglement thing doesn't make any sense if you concede that gravity's a real force. So if you actually believe gravity's a real force, then everything's being de-entangled every trillisecond. That no photon could travel almost any distance at all without being affected by gravity and therefore unentangled. It's essentially having its picture taken by gravity. Yeah. And look, and this doesn't get to even the morons who take this little tiny grain of evidence and then turn it into, our minds are creating reality.
But in relativity, Everyone carries on just as if they were all teaching one and the same interpretation, the one they call Einstein's. The problem is, few people are acquainted with Einstein's actual work and don't know that Einstein never really had a solid interpretation of relativity.
I don't know if Einstein would appreciate that comment, but, whatever. Clearly, he hadn't thought it all the way through, you could argue. So, he wrote his first book in 1905, and then he had revised it by 1915. And he continued later to write a defense and another, to some of the counter arguments. And yes, some of it was sort of weak sauce, you could argue, because, he didn't have immediate answers to this. The problem of absolute space was a real problem because I think he was reluctant to have to concede he has to destroy that notion that there is no absolute space. Because the only way this relativity thing could work is that you do have to essentially destroy it, because you end up creating frames. They have frames inside of frames inside of frames, and you can end up with light going much faster than the speed of light. So unless you get rid of the absolute space, you can't really play this game with the speed of objects.
Most people teaching relativity are unaware, for instance, that Einstein himself didn't believe in the conventional solution to the twin paradox.
It's a nice picture of Einstein, I have to admit. That's a nice rendering. All right. So whatever the standard solution is. So I can't remember Einstein's solution, frankly. But this is the one where I think he was saying neither object is in absolute space. And so there's no obligation for one or the other to actually be moving, which didn't seem like much of an answer, frankly.
Or in absolute acceleration. That he didn't believe in black holes. That he didn't believe in cross terms of the line element. That he didn't believe in the geometrization of gravity. Or, most shockingly, that he did believe in the ether. Or at least that he reversed his stance on it in 1920. When before an audience...
So we know 1920 is pretty early, and, but yeah, so he's made a few statements about it as if he's saying, look, the default is it's going to function, as an ether, in the sense that he was playing that game with the whole, how the energy moves through the universe, in the sense of giving it no material form. So it's almost like it has to be, the default is that let's just say, put it this way, if you're going to say space is bent, then don't you have to make it out of something to bend it? So that would be the argument, I guess. The simplest argument is, if you're going to say there's such a thing as a bent space, you can't bend nothing, so there must be a something to it. So if you want to call that ether, well, then that's an ether, because there has to be something that's bent. You can't have a bent geodesic made out of nothing. It has to be made out of some sort of structure that's actually being bent. Something like that. But I don't think it's any concession to any idea that there's only something in the universe and there's no such thing as a nothing. That there's no empty space. So I don't know if he'd say there's no empty space.
At the University of Leiden, he declared that general relativity necessitates space be endowed with certain physical qualities. And since the special theory...
Right, so that just makes sense, right? You're just saying if I can bend it, then it's got to be a something. So if you want to call space ether because it has to be something, but you can't bend nothing, okay. But I don't think he was going for any more than that to the ether. The only thing it did was this bending thing. It didn't do anything else. It's like the only property it had is its bendability.
Theory of relativity does not compel us to deny ether, that therefore there exists an ether. Indeed, a number of major shifts in Einstein's interpretation of relativity can be traced throughout his lifetime. And he died...
So some of this is interesting. Okay, absolute acceleration kinematically makes no sense. So that's an interesting, statement. This Mach's principle stuff modified. This is where Einstein took a separation with Mach. So they were sort of colleagues early on, and Einstein left that building, 1930 something. But there's no principle here. Mach's principle modified. There's no principle. He's just basically claiming that gravity is being created by everything else in the external universe, but he doesn't provide any method or means or way for that to happen, so it doesn't make any sense at all. I mean, the simple definition I would give is that you either believe there is force in the universe or you don't. I don't understand how there's any complication here besides the fact that you see the sun radiating these photon things. You know that the universe is full of this invisible crap that you only see, okay, when it impacts you. It has to hit something, okay, to mean anything. So it's completely invisible until it interacts. And that's it. And, and it's moving the speed of light. So it seems to me that's the elemental stuff in the universe. And that stuff is how everything else communicates. That's how everything else gets affected by something. That's the definition of the origin of every force. That's the stuff pushing the matter, is the stuff moving the speed of light in the empty space.
Never really having made up his mind about what the theory actually meant. In his wake, he left an...
I don't think that's the statement. The statement is I think Einstein, unlike these turds, was being a little bit more honest about how, well, we're all talking like we are great physicists and we've answered all these questions. And Einstein, I think, was pretty much saying the older he got, the less satisfied he was with these answers. These aren't good enough. They don't answer all the questions. It isn't consistent. It has these incomplete aspects, okay? And by incomplete, he was saying self-contradictory. I mean, basically, that's the incompleteness. It has a giant frickin', it's got a giant flaw in the picture. You've connected some dots, but now the dots don't work anymore. There's a big pile of the dots that just look like a tumor. I mean, it's not, it's not Mickey Mouse.
Immense philosophical vacuum, which
So that's a good picture.
Modern physicists are still trying to fill in with their own ideas today. The result is an extraordinary and inordinate confusion, which you can see clearly on display in the wide number of personal interpretations that professionals give to their explanations.
Right, so that you should say that about yourself too, that you have your own personal interpretations of what facts you've accepted as true, and you're going to write your silly three bear story based on what kind of furniture and what kind of yes, the Papa Bear does smoke a cigar, and yes, Mama Bear has, she has to go to the salon and have her hair done. You have your own elements of the story that you've accepted and you've thrown in there. And I would argue that, in my opinion, all of it, 80% of it, okay, is wrong axioms. You've accepted a bunch of crap that hasn't been truly demonstrated to have anything to do with reality, like calling time a dimension.
Such differing interpretations can be found in any number of YouTube videos, but today we're going to pick on one in particular. Sabina Hassenfelder's Why You Misunderstand Relativity. Now, we enjoy Sabina's channel, and we were, in fact, greatly appreciative of this.
So this gets to stuff people bring up, this stupid acceleration, where like acceleration and velocity are two opposite concepts or something, when frankly acceleration is just a change in your velocity. So something acts on you, a bump in the road, and it changes, okay, how fast you're going, so you've been decelerated or accelerated because of some interaction. And there's nothing particularly different about the two events, except one, your velocity is changing, and the other one, your velocity is constant. So what? Why can we use this as an excuse to say they're somehow different things? Because they're really not. It's not so much about, how fast you're being accelerated. It's just about how much force is affecting you. So again, gravity is about rain. You don't say the rain, when it's raining on you, the rain is accelerating me. You don't worry about it in that concept. You understand that there's a certain amount of material force that the water represents, and that you're going to be hit with a certain amount of material force, and that material force is going to change where you're going. And that's all there is to it. It's not, you don't have to make these things like one is a squared function and one isn't. That kind of nonsense.
Video on the whole, since it corroborated our own video from a few months earlier about how you're accelerating up at the surface of the Earth.
Right, so that's just too silly. When the net acceleration is clearly into the Earth. That's the net. The first act is to push you in. All you can do is restore yourself, undo the first act, but the first act always comes around and bites you again. So you're never catch up. You never accelerate out. You clearly are in some form of deficit. You're in some form of being pushed into the quicksand. I mean, if I push you into quicksand and then you manage to get back up to the surface again, and I push you back into the quicksand, you don't say you're not in quicksand. No, the default is you're in quicksand, okay? Most of the time, you're in the quicksand. That's where you are. That's your, net state is being pushed in. Your net state isn't being pushed out. And they're only doing this crap is because they're negating the force that pushed them in, because they're saying you can't feel it. Whether you can feel the force or not doesn't mean the force hasn't acted on you. So that's the stupid part. Gravity is you don't feel the force of gravity. You do feel the earth push you back.
But on the flip side, this video also brings several contradictory statements into immediate proximity to one another, and in doing so demonstrates just why relativity is...
Okay, acceleration is absolute. Everything is absolute. So again, this whole idea that there's not a real universe and that everything happens in the real universe in an absolute manner. There are things that happen simultaneously. This and this happens simultaneously in the universe. And it doesn't change that reality one motherfucking tiny bit if there's some asshole way over there who sees this first and sees this second. Who fucking cares? What does that have to do with reality? The fact that your perception is being controlled by the time it takes for the information to get to you doesn't have anything to do with when the event happened. It happened at a specific time, okay? I mean, a nuclear bomb goes off in some country and the radiation doesn't get to my house for 17 hours. It has to go all the way around the planet and then get to my house. What the fuck? Am I going to say, oh, the bomb didn't go off until the radiation got to my house? That would be stupid. I mean, I'm smarter than that. I can figure that out, that no, it went off 17 hours ago. So, yeah, we can understand that we can be fooled by our position when we view something. Forest tree problem. Okay, so, but fuck this idiotic notion that there's no reality. Alright, acceleration causes time dilation. So, again, it's velocity that does that. So that is absolutely wrong of her to imply that somehow you have to have a changing velocity to be time dilated, when no, all you have to do is have a velocity to technically, by their definition of what happens when you have a velocity, to have your clock break. So yes, acceleration causes time dilation. It's not right because velocity causes clocks to break. So you just replace time dilation with clock breaking. You're allowed to believe it's just clocks breaking. They really haven't proven time got broken. Alright, time dilation is real. Yeah, well, that's the big... Maybe he's going to actually argue that this one isn't actually true. But who knows? We don't know what he's actually going to argue.
So badly in need of better interpretations. No, this isn't an attack personally on Sabina in any way.
Yeah, it should be, though. I mean, the fact is that all this stuff is stated in this hyperbolic way where they all claim this is incredible evidence when the evidence sucks. Again, you still haven't shown me it taking 4 times the fuel to go twice as fast. So, You haven't proven any of this crap with any kind of hard, good, substantial evidence. There's no DNA, there's no fingerprints. You got very little. You got a squeaky, it's like you're talking to your cat, and your cat said, he done it.
And she has plenty of great content. But we do feel that her arguments in this video are representative of the confusion of the greater physics community as a whole. Now, the video gets off to a strong start, with Sabina emphasizing the formalism of relativity over its philosophy, and explaining that our confusion about...
Alright, so she just showed the stupid, whatever, Lorentz, what do they call it, interpretation thingy. And all that is a gimmick. I mean, it's just a gimmick. Let's just multiply the number times a decimal, a number that's always a decimal, a fraction, and therefore we will stop our equation from getting unsustainable.
Relativity stems from the simple fact that we're treating time dilation too literally. That is, taking it to be something physically real when it's rather just an artifact of how we choose to do measurements and draw up coordinates.
As we choose to ignore the fact that what you see, that is how long it takes the photons to get to you, has absolutely nothing the fuck to do with when the thing actually happened. So when residue finds you, it doesn't have nothing to do with when something happens. Things happen when they happen. They don't happen when you, from your perspective, finally got the message, okay? Because it takes a while for the Morse code to get to you, doesn't mean the event happened when you got the message. I mean, it's just too stupid. It's like saying that, somehow... if you had the messenger and the messenger could drive in a good car or a shitty car, and so he could drive 10 miles an hour, or he could drive 70 miles an hour, and depending on what messenger you send, somehow the event took place at a different time. I mean, it's just that silly, and you're saying, yes, of course, it can't be that silly. Nobody should be that silly to think that it matters when you see something happen, because seeing is waiting for the messenger.
The time that passes between two events is not the time on the coordinate axis. That's just a label. It's convention. It has...
So there's no coordinate here that's actually in the three real dimensions. So just understand this coordinate, they're again talking about some fourth dimensional coordinate that doesn't have a damn thing to do with reality.
No physical meaning. This is what people often call time dilation. I'd call this pseudo-time dilation because it's a meaningless comparison. Why would you care about the coordinate time? It's just a label. It has no physical meaning for Bob.
All of this is great, and it seems very in keeping with Einstein's original 1905 special relativity paper, wherein you won't find too many grand statements about the nature of space and time itself, but rather just a simple demonstration.
Right, that this simultaneous somehow doesn't happen, when of course it does happen. And it has nothing to do with it whether you see it. When you see it doesn't mean anything. Can't possibly mean anything.
How adopting light as a basis for our spatiotemporal measurements conveniently reproduces the already well-known at the time Lorentz transformations.
And they're not... Again, this is a nothing equation. This equation is just saying, okay, I'm going to divide something by a preposterously giant number. This number will never be as big as this huge giant number I'm dividing it by, so I'm always going to end up with some stupid little fraction, and that way I can always take that fraction off this other number and make sure it never goes over 1.
But a few minutes later into the video, while Sabina is discussing the twin paradox, she gives us this statement.
Where he travels. This is the real time dilation. It comes from the acceleration. This is the real time dilation. The real time dilation.
The real time dilation.
So it really doesn't mean anything, right? It is too insensible to say that you're doing this stupid time breaking of the clock. You don't need to accelerate a clock to break the clock. All you need to do is move the clock to a high speed, and then it's breaking constantly because the clock is constantly not ticking at the right time.
Like, what? First, she was telling us we were confused about relativity because we were treating time dilation too literally. And now she's saying time dilation is something literal. And to understand the theory, you need to accept a fact that only minutes earlier was stated to be the source of your confusion. Again, like, what?
So that's not really the problem, okay? Because she had already known where she was going, in the sense that she was saying it's not about velocity, it's about acceleration. And this was her response video to the other guy, Bob, whatever, what's his name? Don Lincoln. So she was making a direct response to another YouTuber making a bullshit video. So she was correcting his interpretation, which was it's just about velocity and it's not about acceleration.
Let's slow down for a second. More precisely, Sabina's saying here that time dilation is only real for the special case of acceleration. But as she implies in the beginning, it's the idea of any sort of time dilation being real that confuses people. Indeed.
So that's really not what she was saying. So I guess you're misinterpreting her to say that she was implying that time dilation doesn't exist, when that's not what she was saying. Now, maybe he's going to say it doesn't exist. That all this bullshit, all this whole conversation is about an illusion, not a reality. Now, that'd be nice if that's what he's going to say, but doesn't seem probable.
By saying that time dilation is only real for acceleration, she thinks she's resolving the source of our confusion. But she's not.
She's saying, what's the cause? What's causing the time dilation? Is the essence of the time dilation in the process of accelerating, getting from 0 to something close to the speed of light? Is that process intrinsically do all your time dilating? Or is the time dilation a process that happens while you're at a velocity that's very, very fast? So I would obviously argue that, all you need is the velocity. You don't need the acceleration happens in a millisecond or happens over 10 years. It doesn't really make any difference. All that matters is that you're going the velocity, because the velocity is the key ingredient to making the rest of the universe disappear.
She's merely transferring it from the case of velocity to the case of acceleration.
And that was exactly the point of her video, though. Her whole video was to argue against somebody who was saying that time dilation just has to do with acquiring the velocity. It doesn't, having the velocity, and it doesn't matter how you acquire it. And she's arguing somehow the acquisition is the key point, moment, and that what the consequence of the acquisition isn't the key point, which to me can't make any sense, because the time dilation will happen based on how long you're going the velocity. The longer you go the high velocity, the more time you dilate.
Secondly, she neglects to mention that observers who aren't accelerating will not perceive the same manner of time dilation as those who are. In a uniform gravitational field, for instance, observers who are stationary within the field, i.e. those who are accelerating...
So let's just understand that field could be understood as just being particles of paint, and you're just saying every time you get hit by a particle of paint, okay, against your motion, it slows you down, and every time you get hit by a particle of paint for which you don't have any opposite of motion, will cause you to have motion. It's just money, you could say, being thrown at you. Well, that's the wrong analogy.
We'll see clocks at different positions tick at different rates.
So whatever that means. Okay, so I put a clock in these different pieces of space, and somehow they're going to run at different rates. Well, yes, if these are accelerating at different rates, or they're moving at a speed of different rates. But we know that the force of gravity is all the same rate. It's all moving the speed of light, so all of their clocks are matching.
But an observer free-falling in that field will see those same clocks all ticking at the same rates, no matter what their location.
So again, it's not about seeing a clock tick at a different rate. It's about when does the information get to you. So all you're saying is you didn't see the clock until later. All the clocks were ticking the same exact time, You're just, again, using this stupid perception argument. When did the information get to me? It takes the speed of light to get to me. So any kind of big distance means somehow I've distorted when it happened. No, I can't distort when it happened. I'm just distorting when I see it.
Thus, any observer not sharing in the acceleration won't be able to agree on the time dilation of the clocks. So, by no means can we claim accelerated time dilation to be any more or less real than velocity-based time dilation. They both are coordinate observer-dependent phenomena.
And again, there's no reason to believe you've changed a clock because you saw it later than somebody else, because you were twice as far away from the object, the light bulb, and it turned on, and it took longer for the light to get to you than it took to get to somebody else. What the fuck? Why should I think that means anything? It means nothing. It doesn't change when the light bulb actually turned on, and I can perfectly understand. I can draw a picture, a model of the light moving through space, and I can say this is a unit of time, and this is a unit of time, and this is a unit of time. So why do I need to do any of this crap? What compels me to be obligated to believe any of this crap?
Critics agree. Disney's Peter Pan and Wendy is a soaring adventure filled with beauty.
Now, Sabina does point out that a more meaningful comparison of time ought to happen when observers are rejoined at the same place to compare clocks, which is why she brings up the twin paradox. But she gets something very wrong when she says that the real time dilation comes from acceleration. The asymmetry of the paradox certainly comes from acceleration. But to Alice, Bob's velocity or kinematical time dilation is very real and the cause of his slowed aging.
Yeah, you have to look. If you accelerated and then decelerated immediately after, you wouldn't have spent much time going faster than light, fast as light. So therefore, you wouldn't have spent much time breaking your clock. Your clock would go back to working again. So yeah, it has to be about the absolute velocity. It can't be about anything else, and it really has to be about some kind of absolute velocity, because only one of the twins in the twin paradox can be doing this. Yes, you could theoretically have them both going half the speed, and but the amount of dilation you're going to get is much lower then, because the fact is that they're you have to add their velocities in opposite directions. No one's going any real velocity anywhere near the speed of light, and they're only going a fake velocity because they're moving towards each other. Moving towards each other isn't going to, warp any time.
And to Bob, Alice's kinematical time dilation is likewise also very real. But now in his case, there's an additional accelerative time contraction which he has to add atop the kinematical dilation. Thus, it's actually the kinematical and accelerative time dilations/contractions taken together that describe the real proper time.
So is that cleared up for you? The kinematical time dilation, whatever the fuck that is. And now you have plus the accelerative time dilation contraction, whatever the fuck that is, equals the elapsed proper time. And we know none of this has to do with any proper time because, frankly, there's only one time in the universe. I mean, it's right now here, and it's 13 billion light years away from right here. There's a real thing happening, okay? It's not the thing we see because that light took 13 billion years to get here. But there's an actual real events taking place in all locations in the universe, and they're all happening this moment, this moment, this moment, this moment, this moment. All right, and because it's going to take 13 billion years for us to see what fucking happened there, fucking so what? What does that have to do with anything? Oh, that's right, it has nothing. It doesn't prove anything, doesn't demonstrate anything, doesn't mean anything, doesn't change anything. It's nothing. There's no such thing as this proper time. There's only time, period. It's the same for everything. Everything in the universe is on the same clock. It's in the same universe. It's interacting in this one reality There's not a bunch of parallel times interacting with each other. There's just one time and one physical universe with 3 physical dimensions, and everything is interacting in that realm, and there's no good reason to believe anything else. Except that clocks are broken by velocity.
If you leave either of them out, the math fails. Now, if you want a quick and dirty rundown of the math,
math fails because it's contrived crap. Okay, it isn't based on a formalization of anything real. It's a formalization of a bunch of abstractions, and of course the abstraction of a 4th dimension and some place called a bendable space. There is no bendable space, and there is no 4th dimension of time.
I recommend you watch this short video by Minute Physics. It's simple and easy to follow, and it will give you the necessary insight about why kinematic and accelerative time dilations and contractions need to be taken together.
Whatever that meant. Okay. So they, whatever they mean. Whatever they mean. Does it mean that one of them has to be doing the moving and one of them's not moving? Can we do that example? Show me the example where one is moving and one is not moving. And then show me the example when one's moving, half the distance towards the other one, and the other one's moving half the speed towards the other one. But more importantly, do the example where they pass each other, and one has a 10-pound weight hanging out the window, and one has a 5-pound weight hanging out the window, because that's the way to tell which one's moving.
Indeed, saying only accelerative time dilation is real while kinematical time dilation isn't is not only incorrect, it's also not an explanation you'll come across in any textbooks or historical works. So Sabina's being...
So he just pointed out earlier in the video, right? So he's pointing out her contradictions. He just pointed out that he also sees these wrong answers in textbooks and other videos. So, so why should I accept that what one pile of textbooks says so and the other pile of textbooks says something different? So where did you prove your textbooks are the right ones and those textbooks are the wrong ones? Oh, yeah, that's right. You're not going to prove it. Certainly not going to prove it in a 15-minute video, but whatever. Cheap shot, I would say. A cheap reference to authority. Our authority says so.
A little disingenuous here in claiming she's teaching Einstein's interpretation, as she's actually just teaching her own. Additionally, earlier in the video, she actually rejects Einstein's preferred explanation to the twin paradox, which is the gravity-based one. Of course, as we discussed earlier...
I mean, what the fuck could gravity have to do with it? You're just almost arguing. Can't I set up this paradox? Can I set up this traveling twin without introducing gravity at all?
It's likely she's entirely unaware that Einstein even had a preferred solution to the twin paradox.
Alright, for one, it is a great satisfaction for a consistently, metrically, let's see, I think maybe that's mathematically, makes no sense anyway. Oh, okay, I broke the sentence. Consistently thinking man to understand that the concept of absolute movement, which kinematically makes no sense anyway, need not be introduced into physics. Okay, so a thinking man to understand that the concept of absolute movement. So again, that's a clear statement in his youth about how he doesn't think there's any such thing as a real universe, frankly. That somehow things aren't moving in 3 real dimensions. And I would say, how can a thinking man not recognize that? So, I can't even understand how you could say something that fucking stupid. For one, it is a great satisfaction for a consistently thinking man to understand that the concept of absolute movement, which is kinematically makes no sense anyway, which kinematically, in my sense, makes perfect sense. The fact that there's little stuff moving the speed of light communicating between a bunch of big stuff very far away makes absolute sense to me. I don't know how the fuck you make that not make sense. Anyway, need not be introduced into physics. Well, anyway. Sorry, too silly. too silly for me to even try to sit there and imagine your fake universe where there's a bunch of non-connected space that things can do that can spread over each other, that somehow can extend into each other. No, it doesn't make any sense at all to me. That's an amazing quote, frankly. I have to go find that one, I guess, and see what the fuck else he was saying that was complete shit. I mean, as many times as I want to be sympathetic with Einstein, because at least later in his life he was kind of pointing out how everybody's full of shit. This is a full of shit statement.
But this just demonstrates our point that nobody knows exactly what interpretation of relativity they are teaching, and generally they just fill in the gaps in their understanding with their own ideas. And here, Sabina's own ideas are quite in confusion.
All right, so I'm just going to advocate for the simple fix for this whole problem, which is forget all these abstractions and just deal with the idea that there's a three-dimensional universe and that time is just a function, and that the only thing happening is there's little bits moving the speed of light that are force, okay, and they're hitting big bits, okay, that don't move the speed of light and push them around. I mean, why can't that be reality? Yeah, I don't think there's any outstanding fact that says that can't possibly be true. There's no kinematics that say that doesn't work.
As it's clear she can't decide what level of ontological reality to ascribe to the phenomenon of time dilation. Indeed, physicists being unable to make up their minds about what the meaning of time dilation actually is.
So it doesn't mean anything, but she's basically saying that I think she fully understands that all time dilation is a perceptual thing, because you're saying that because I'm going fast, my heart beats slower and everything slows down. And that's the only way I can perceive the flashlight that I turn on, the photon to leave at the speed of light. The only way the photon could leave to my perception at the speed of light is I would have to be in some special condition where nothing's happening. I mean, it's happening so slowly because I have to force the light to look like it's not going faster than me, when in fact it is. So again, the whole story is stupid, okay? The fact is, if I'm going 99% the speed of light and I turn the flashlight on, the fact is the light isn't going to leave me at the speed of light, because I'm going the same direction it is. And the fact is, I can't change that physical fact. The fact is, in the 3 dimensions, the light's moving this fast, and in the 3 dimensions, if I'm going almost the same speed, I can't make a new photon that goes the speed of light faster than me. I can't do it. I'm already going almost its speed. It can't possibly leave my flashlight faster because it can't go faster than the speed of light. So, I mean, it's just... They say they somehow proven the physical universe isn't like that, when I'd argue there's no such proof. The physical universe says no. So the whole point is they're saying you are moving so slow. See, you're only incrementally the photon leaving your flashlight. You're going 99% the speed of light. The 1% that the photon is going faster than you from your, that's leaving your flashlight, that 1% has to be turned back into 100%. So you have to wait for it. So the idea is you have to take a whole bunch of time and let time tick, 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 tick. So it looks like the photon left you really fast. So you're basically just pulling a bunch of frames out of the movie to make the movie shorter. So you're just saying you're perceptually not interacting anymore in the real world. You're frozen. And that's all this time dilation would be, is that somehow you mechanically stop moving, stop functioning, so you can allow a bunch of time to pass to allow the photon to get further away from you. Because it's going to need a lot of time to do it when it's only 1% faster than you.
Is probably the biggest source of confusion in relativity, and why you get such backwards ideas like time dilation causes gravity. Is time dilation something real? Something that should modify our idea of true, immutably flowing time? Or is it just an artifact of how we've chosen to formulate our theory and draw up coordinates?
Look, it's just a coincidence that you can play this game, okay? All you're doing is trying to duplicate an inverse square law, and yeah, you can do it lots of different ways in terms of creating fake bent geodesics. So yes, you can create some contracting vacuum cleaner space that just sucks everything to the core of the Earth or something, and you can draw that image. But that is just drawing an image that duplicates the circumstance. It doesn't explain the circumstance, where I can offer you an explanation and say, well, every time a little piece of force has to go through the Earth, it's going to interact with matter and it's going to push it. And every time it pushes a piece of matter, it goes from going the speed of light to going 5 miles an hour. It basically slows down, which means it can't have the same energy because it basically spent some time slowing down. So its overall velocity in the universe has to be something less than the speed of light because it spent some portion of its time going less than the speed of light. So its average velocity is less than its any at one moment velocity, and that means that its average velocity has declined. And it declined while it went through the Earth, which means the deficit is going to be felt in the sense that less energy is going to come out of the Earth than went into the Earth because the energy wasted time pushing matter.
This is where the formalism of relativity doesn't provide any clear answers, and consequently, where the personal interpretations begin to flow.
So he keeps saying it. He just keeps saying the personal interpretations. There's no personal interpretation of what is in that on that drawing board, the Lorentz contraction thingy. There's no personal interpretation that somehow because I'm closer to one event that took place simultaneous with another event, because I'm closer, that somehow I can legitimately say the two events, I can tell you, I can give you a false narrative of the fact that the two events weren't simultaneous merely because I was closer to one. I mean, that's just too silly. Of course, you can't make that statement. That would be being stupid. To say I undid their simultaneousness merely because I changed my position in space, looking at it. So I look at it different, somehow I changed the painting. Bullshit. You didn't change anything.
If we want to treat time dilation as something real, then since different observers don't perceive the same manner of time dilation as one another, we seemingly have to accept a solipsistic worldview where different observers can construct different narratives of their...
Oh, whatever. So this is just such baby talk here that we have to accept a solipsistic view where somehow observers are changing the universe and blah, blah, blah. It's all this. This is just such goddamn religion. Ugh, puke. Oh, it's all what you believe. Doesn't have anything to do with reality. If you believe you're beautiful, you're beautiful. La 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 la. It's just what don't compare your penis to a walrus. Compare it to a nuthatch, and then you'll feel good about yourself, and that'll be the reality.
Their existence. On the other hand, if we reject the reality of time dilation, we're left scratching our heads over just how it comes about that certain...
So that is not a problem, frankly. It's really easy to understand why radioactive elements would be affected, how decay happens, because we don't know how decay happens. I would argue we do know it's an external cause, and you're just waiting for the external circumstances to create a unique event, a little unusual event. So I have argued this, and so it's probably not this simple, but I'm just saying it's like, okay, when Luke Skywalker destroyed the Death Star, okay? So you could say that the only time this event happens where there's this atomic nucleus, and the fact is that a piece of photon has to come in from both sides at exactly the same time. And if you have energy come in at exactly the same time from both sides of the atom, that breaks the atom, okay? It causes the fracture and the atom splits and ends up creating radiation. So it's for each atom how difficult it is for that event to happen, how big the hole is that the light has to go through can be different. That's why it has a different decay rate, okay? It's because it's just waiting for that You know, it's waiting for that roll of the dice. It's rolling the dice, rolling the dice, rolling the dice, and they have a million sides, and it's just waiting for the million-side dice to show up with the, 5 sixes or whatever, the Yahtzee. So it's just waiting for the Yahtzee. And each one has a different probability of the Yahtzee happening. And the simple truth is when you move the atom in absolute space, when you give it a velocity, its decay rate will change. So depending on its velocity, its decay rate changes. So here on Earth, in Earth gravity, when uranium is here and uranium is over here, the uranium atoms take 10,000 years to wait for that unique event. But if I give it a velocity, I change how likely that event is going to happen, what the probability of the event is. And so if I put it in a different gravity, its decay rate changes a little bit. If I put it in these different circumstances, I'm going to change the probability of the event because I've changed the external world that's traveling through is now different. It has more stuff hitting it from one side than the other side. So now I've changed the likelihood of the event. Some simple mechanical explanation can explain why this particular kind of clock, an atomic clock, breaks. Every clock has its vulnerability, okay? I mean, none of them have an infinite amount of licking and keep ticking. They all have limitations. So that's the simple explanation. You don't need a complex bent the whole universe because you broke an atomic clock.
Certain clocks can be empirically observed to run slower or faster than others.
Right, and it means absolutely nothing, okay, if you understand that the material universe is what they're existing in, and they're actually moving through a field of energy, and that obviously that could affect the decay rate, just like me taking the uranium atoms and putting them next to each other, and all of a sudden I've taken a 10,000 year decay rate and I've turned it into 10 minutes. I mean, it doesn't take much change to change the decay rate. So it would be silly if you had some evidence that the decay rate was something inside the atom and something inside the atom had to happen. Well, then you might have an argument, if the decay rate was absolute. But it's not absolute. It's completely controlled by environmental circumstances.
But what if it were the case that there were other interpretations of relativity out there? Interpretations that reproduced the formalism, but which steered clear.
So I don't know what the formalism. See, I mean, that's what math should be, okay, is you're just formalizing, okay, a simple relationship. So you're taking a simple relationship, turning it into a little formal, a reduction, a simplification of the essence of it. So you're just describing the essence, okay, not all the details, just the essence, the basic function. So what's the basic function of all of this crap? There's no basic function here because your axiom is let's bend the universe. Your axiom isn't let's find a reason to say that formalism exists.
Of the heavy-handed space and time.
Oh, he talks about heavy-handed. And this whole video is heavy-handed. All this propagandy images and shit.
Altering pseudo-mysticism of relativity altogether. Interpretations in which there was no time dilation or spatial contraction to begin with. No relativity of simultaneity or...
There you go. Yeah, well, that one's so obvious. I'm just saying, isn't that one insanely obvious? That you cannot change when an event took place merely because you said the photons got to me sooner or later. I mean, that's too frickin' stupid.
Funky stretching or shrinking of measuring instruments. Would you feel you deserve to know what these interpretations are? Or do you think physicists should go on teaching relativity as it currently stands? A theory with a perfectly functioning formalism. But
I don't even know what they mean. I don't know how is this moronic nothing a perfectly functioning formalism? And again, the very idea of squaring the speed of light as if there's some reason to believe the universe has any notion of squaring a velocity, a linear thing in one dimension. Why the fuck would the universe think that was a brilliant idea? I mean, what Pythagorean geometry can you defend squaring velocities with?
with its philosophy caught in a limbo so uncertain that even Einstein couldn't make up his mind about it. Well,
Einstein couldn't make up his mind about a lot of stuff. So that's the whole point of Einstein is that Einstein didn't care for all of these leaps, okay? But the irony was he did like his own leap. So his leap of bending space he liked, but he didn't like everybody else's leaps to entanglement and this and all the other abstractions. So that was his hypocrisy. So, I mean, we're all probably, these prejudices and biases can be found in all of us. But I would argue that, yes, I mean, you know, Einstein's brilliant work was the idea that he looked at a couple of circumstances like the photoelectric effect and Brownian motion and figured out a way to say there's a clear correlation that we can draw from this and say that we can tell how much atoms are moving because we can see the emergent property of the atoms moving. You know, that kind of, those were great observations, but the rest of this theoretical crap was crap.
we can't make that decision for you, but we can say that if we want to move towards a more consistent interpretation of relativity, we need to re-examine one assumption of relativity in particular.
I thought it was an interesting quote, right? So 2 years before he dies, his quote is basically saying, I've been studying photons for 50 years and I haven't improved my understanding one iota. Now, clearly, I think he had, but that understanding was still stuck in the sense of how do you deal with this wave-particle duality thing? It really doesn't make any sense. The whole thing looks very discrete, yet it somehow is, you know, photons don't. I mean, the whole idea of a photon interacting with an individual electron in space. I mean, there's so many logical arguments where you can say, how the fuck could it possibly do that? How could it have a mile-long wavelength and expect the electron to be in the same place while the photon is traveling a mile, taking what is basically a huge amount of time from an electron's perspective? From an electron's perspective, a mile at the speed of light is a gigantic pile of time. How could the electron possibly be in exactly the same space waiting for the rest of the photon to show up?
Assumption of absolute acceleration. Indeed, it's this assumption which Sabina uses to justify her interpretation that only accelerative time dilation is real. But it's an assumption Einstein could never bring himself to accept. Indeed, if you...
I wish you would read these things. For one, it is a great So he's reading the same thing again. So he's saying there's no absolute movement. Okay, fine. I'm just saying I have exactly, profoundly, and passionately exactly the opposite kinematic view of reality. That there's no way to explain it as a bunch of frames layered on top of each other.
If you want to know Einstein's actual thoughts on the topic, we suggest you read his 1913 paper entitled On the Relativity Problem, because you might be surprised by what you find there. We also suggest you watch Sabina's video more carefully around the 17-minute mark and ask yourself why she says that the spring which is brought in there has to come from outer space. Indeed, a more thorough examination of the problematic notion of absolute acceleration will help guide us towards a better interpretation of relativity. We're saving a full treatment of that topic for...
So what's the difference? I mean, again, I don't know exactly what side. You can't, the way he did this whole thing, it's hard to say who's he's defending. So I think he's defending Einstein's statement that there's no absolute acceleration. Well, the whole point is there absolute positions in space? Is there absolute velocity? So if you're saying there's no absolute acceleration, there is absolute velocity, I mean, what's the point? You're saying there's no absolutes in the universe. And I'm just going to argue, how do you know? You don't have enough evidence to close that reality. There's no real fact that screams you cannot believe in things having a real velocity, when of course you can. I mean, Galilean relativity does work. I mean, just recognizing that things can be moving collectively, and the collective movement can create its own little environment. And the fact that you're all going this way isn't going to have any effect on all the other interactions you're going to have. Because you're all doing it.
For another video. But for the moment, we can with certainty say that this statement Sabina gives us at the end of her video is not correct. And rather than clarifying things for her viewers,
I don't see where he proved that, but whatever, who cares?
It merely demonstrates her own confusion about the theory. Which, of course, brings us to the real reason you don't understand relativity. You don't understand it because the people teaching it to you don't understand it.
You don't understand it because it has contradictions built into it. Because it's making a statement that frankly isn't right. It's just wrong to say there aren't 3 dimensions of space. It's just wrong to say that things can travel in that space in some way where they can negate the fact that it takes time to get from point A to point B, and that the fastest you can go is the speed of light and everything else has to go something slower. And there is no real thing that can do anything other than that.
At the end of the day, this isn't a huge deal, as quantum mechanics demonstrates that you can teach a formula.
Oh, fuck. Quantum mechanics. Look at the little x squared here. You know, squared, squared, squared. All these little squares. These aren't geometric objects. There's no point in squaring them. You're not doing Pythagorean area math. These things don't make areas. There's no volume to your velocity. There's just a magnitude.
Just fine without the accompanying clarity of philosophical principles. However, the first step to overcoming a problem is admitting that you have one. And relativity, unlike quantum physics, suffers from a serious case of denial.
Oh, amazing. Unlike quantum physics. I mean, really. Quantum physics has these loop-de-doo, completely divergent explanations for everything. It's just mush. Multiverse versus, entangleverse versus superimpose-averse. I mean, come on. What a pile of shit to make this comparison and say relativity looks like crap compared to quantum mechanics. No, they both look like crap.
But if you, like us, are after the truth...
Like us. Oh, isn't that just such a kind of religious thing or something? If you're one of us... Are you an us watching this video? Are you one of us?
Then you know no harm can come of asking critical questions and exploring new ideas.
Yeah, but it sort of does come when you say something overt like she doesn't understand. I think she's going to find that irritating. It'd be interesting if there was her response, but nothing's pinned, so I guess we'll have to wait and see. But it seems provocative, let's just say. And again, he's taken away the context that she made her video in response to this very same argument that there's all these people talking all kinds of shit. So obviously, yes, she decided to say her shit is the stuff that doesn't smell.
So hold onto your socks, because our channel is about to move into uncharted territory.
Blah, blah, blah. And the uncharted territory is what? Mind over matter or something? I don't know. I don't know exactly what he was saying. So he believes in the mindiverse or something, or he doesn't.
This has been Dialect. Stay tuned.
Yeah, whatever. We'll see. So, yeah, I'm sure he got plenty of whatever fart back. Most helpful, and can remember after reading many books and seeing many videos over the 30 years, maybe you should have a listen more carefully. Oh, see. So he's telling him he doesn't understand, and you should listen better. So anyway, who knows where he's going. He seems skeptical, which is good, But he doesn't seem like he's prepared to oppose Einstein's statement and plainly just state that, the universe is 3 dimensions and everything happens in those 3 dimensions and you can't escape the absoluteness of it. There's nothing can do anything in some other way than exactly the way we're doing it. And the simple truth is that I can be doing this. It's like a TV signal. We're broadcasting TV, from the 50s is going out in space right now. The radio wave is out there somewhere. And it's taken a long time to get where it's going. And if somebody was way out there, it would take 50 years for the show to get to where they are. So what? They wouldn't. Why would they say, it's happening right now? No, it's not happening right now. It's 50 years later. They could figure that out. I just don't see how it's possible to have a rational verse if you're going to sit there and pretend that somehow when I get the information is when the event happens. That's not when the event happens. It's just crazy. I don't know why people believe that shit. Seems impossibly silly to me. Alright, so let's see what we got in the old chat thingy. And that's over here. Okay, so we can move that in here. And yeah, we'll leave it at that. I won't put any troubles. Alright. Been looking for people to debate you regarding the argument KE versus MV and oh boy. Yeah, well, I mean, they're just going to keep... But it's F equals MA. There is no argument. F equals MA. Done. We're all done by having an argument. F equals MA. And A is squared, so poo on you. Yeah. Let's just say I got kicked off some servers and have met such arrogance beyond reason. Yes, exactly my experience. Yeah, so you cannot challenge. You cannot say... Could you show me one experiment in defense of your theory? You can't ask a physicist that. You can't ask them to show you a piece of evidence. That is like, calling their mother a fat, skanky whore. Okay, I was talking to a few that say you are arguing for free energy, when yes, obviously I'm arguing exactly the opposite. Just like the Newtonians did back in Leibniz's actual error, and they completely defeated him because Leibniz had no counter argument to the accusation except to say, no, you're free energy. And obviously the Newtons said, well, if we're free energy, why isn't there free energy? So if we're for free energy and our science says there's free energy, then why don't we have free energy? I was thinking to a few, I was talking to a few that say you're arguing for free energy, which is just so ironic. Okay, even though I stated countless times that you are against it. Yes, that's the whole point, is that their theory, the theory that conventional physics has accepted, clearly states any time you transfer energy from a heavy thing to a light thing, you will create free energy. The gun does it right in front of your face. 2,000 joules, the shooting out with the bullet. 2 joules with the recoil of the gun. They're supposed to be equal and opposite reactions. Well, how the fuck did I create 2,000 joules going one way and only 2 joules going the other way? It is really bad that these people are either ignorant or scared. No, they're belligerently ignorant. So it's just belligerence, okay? They are just like the religious fanatics. They will not hear the argument. They won't listen to the argument. They'll just run the fuck away from the argument because they do not want to hear that their God is not God. Okay. Hi, Gary. How's it going? How do you think it's going? Is your understanding of the twin paradox that the traveling twin would return and be the same age as the non-traveling twin? Yeah, it's my argument that this doesn't happen, okay? This whole time dilation, aging, suspension thing doesn't happen. So the time will pass for both people exactly the same, okay? And they'll meet and they'll be exactly the same age, okay? You can't change how old you are, and you can't freeze yourself by going fast. Going fast will not cryogenically freeze you. So none of this shit happens. Nothing slows down. Nothing stops working beyond the point where you break something. So you already know that if I move this really fast in the atmosphere, I'll turn it into liquid mush. So I can break this pen just by moving it fast enough in the atmosphere. And the truth is, empty space isn't entirely empty. And so, you could understand that if you move matter through space really, really fast, that the only way you can do that is you have to hit it with an awful lot of cosmic radiation, so to speak, gamma rays. You have to hit it with a lot of energy to make it move that fast. And that giant pile of energy on one side of it, and then it's plowing into the field of energy, So you can understand that this is the faster you make some piece of matter go, that means it has to be an incredibly bizarre circumstance, because somehow it has to be able to travel into a field of energy and maintain a velocity into that field of energy. So I'm saying that atoms can't do that. That the atoms will break down as soon as you go, half the speed of light or a tenth of the speed of light or something. The atoms will start to break because the atoms are dependent on charge, and the charge is made out of these photons, and it has to be going the same speed in both directions. And if something is moving, and then the part of the force that's going to repel the electron can never get to the electron because the electron's moving almost as fast as the force is. I mean, it just breaks the mechanics of things. So my argument is, if you try to go, whatever, 97% of the speed of light or some other kind of silly number to do your time dilating traveling thing, you will fall to pieces. All right. I managed to post your argument on some science debate channels. I don't know where you found all these channels, frankly. We will see if anything catches. Like somebody being able to make an experiment that's founded with evidence. Like they actually show you a link to an actual credible experiment. Yeah. Hopefully we get a physicist to have some integrity to debate. Yes, well, good luck with that. Because I can't find one. I mean, even the small channels. I've asked a lot of people who are, kind of low watt channels, and I can't get any physicist to do it. And I'm offering them compensation. I mean, I'm not offering the nobodies $3,000, but I'm offering them, I'll pay for your time. Just let me know how much it costs. If they could make a reasonable argument, I mean, it's pretty low odds that no physicist hasn't ever seen any of my videos, right? And seen my arguments. Like, you could argue AB Science, all these people, they saw some of my arguments, and they didn't counter them. Okay, let's just understand. They countered them by saying F equals MA or something gratuitous. Some kind of crap. It's well established as a fact. Some sort of shit like that. But I mean, my constant plea to be shown a piece of experimental evidence that demonstrates this to be a decisive argument, where you have proven, that you could establish it as some sort of substantial piece of evidence. A piece of evidence that I can't easily dissect into nothing. If you have a laboratory in a container with no windows. So again, this no windows thing, for what reason would I have no windows? But anyway, let's just play along. Traveling 1% the speed. Are there any tests you can do to confirm you are traveling? Well, yes, I'd say the light clock will do that. So if it's 1% of the speed of light, you could detect, with a light clock. Because 1% is enough. I would argue it's probably enough. So you just send your photon across your ship. And the fact is the photon is going to appear to hit the wrong place on the other side. So you establish where perpendicular is before you go traveling 1%. And then go ahead and do your 1% and then shoot your photon, and you're going to see that your photon's not going to land where you're aimed it. And it's going to be 1% off. So, 1% of whatever the tiny distance would be. So, yeah, I can't say for sure whether we could detect that, frankly. 1% might not be fast enough. You'd have to have a very wide ship. So maybe, yeah, you forget the ship and just use 2 satellites, okay? And give them exactly the same velocity and have them be 3 miles apart, and then send the photon back and forth between the 2 satellites. And I would argue that you're going to find that the light, okay, does not hit the target. It misses the bullseye. The problem is this laser spread, so 3 miles is probably too much, because then you're going to be making this gigantic laser dot. And so you won't be able to find the center of the laser because of the gigantic laser dot. So, I mean, new lasers are better and better, so I don't know how confined they could do. Well, anyway, you just find the, try to have the satellites as close as possible where you can still detect the difference. It's all those tricks you have to do. I mean, I did try to do this experiment in my backyard where I used to live, but there was just way too much shit in the way. And the problem is the very thing I'm talking about. You can't detect if the laser beam gets bigger and bigger, you can argue that it's getting bigger for the very reason of the fact that the center is moving, because of all the compound motions that we have on Earth. So because we have a bunch of compound motions, that is, we're moving on the surface, and then the planet's moving, and then the solar system's moving, well, the sun's moving, and then the solar system's moving, and the galaxy's moving. That's the whole reason why the beam spreads, is because as it's traveling, it's doing this. The center of the beam is doing a lot of direction changes. All right, let me just think if there's any other way to test. I mean, clearly we can test for the difference between gravity and the Earth pushing us, right? We can understand that when you're free falling in gravity, you're acquiring an acceleration, and there's no way for you to feel it because your sense organs all move at the same rate, and so there's no pressure on any part of your body. One part doesn't go faster than the other. Gravity pushes all the little atoms the same way. And then the difference of the Earth doing the opposite. So in a sense, we're saying, can you detect gravity in some way? Is there some way to detect a force like gravity that moves all your atoms? Because the only ones we can detect are ones that push on our chemistry. Where another material object hits us, or a little beam of light hits us in just one place, and we can feel it burn our skin or something. Otherwise, we have no mechanism to detect having velocity, or frankly, acceleration by gravity. So it doesn't do you much good to say, let's see, what's an example? Say you fall into gravity, right? Instead of pulling yourself out of gravity, you would feel accelerating out of gravity. But falling into gravity, if you were just falling into it, how are you going to feel that? You're not. And so that's be an acceleration that you're not going to feel. So you don't feel all accelerations. So it's not just about the difference between velocity and acceleration. It's the difference between forces that push every bit of you and make it sensually impossible for you to feel the motion, and forces that have to push you unevenly. Let me just think if there's any other. I mean, it's something I should spend a day just trying to contemplate. I mean, I thought of the experiment where you can hang a weight out the outside, but I mean that does depend on some sort of interaction with the other object. So you're saying if I don't interact and I just sit in space, how do I tell whether everything's moving or nothing's moving? Without looking at other things moving. So if I can't see anything else in the universe, how do I tell internally whether I'm moving? I guess the argument is I can't tell. If the motion is something I already acquired, then I'm stuck, right? So if I already have it as a velocity and it's not going to be an acceleration, how the hell could I feel it? Because it already happened. Everything's already moving the same speed. All my little bits are moving that speed. How could I possibly internally tell? And then you're saying I'm just connected to a spaceship is the same thing as saying I'm in my mother's womb. I mean, putting me in a spaceship doesn't give me any more information, right? So that doesn't help me any. So I guess that would be impossible unless you have some way of saying I can compare it to some. I have to force the difference to show up somewhere. And if all I do compare it to stuff all moving the same, how can I possibly tell I'm moving if all I compare myself to is other stuff moving exactly the same? I mean, that's a pretty simply entrapping paradox. But we're saying, what experiment can I do in front of me? So what mechanical device could I set up that isn't like me and it's somehow capable of seeing absolute velocity? Yeah, the light clock really is the only thing. You have to have something moving the speed of light because that's an absolute speed. So that's in the absolute universe. So that you can make an absolute you can make a comparison to a relative movement because that's an absolute movement. So some form of light clock is probably your only choice. All right, anyway. Some specified you need a scientific journal. So, so what? I mean, that's just baby talk, frankly. Obviously, these journals aren't going to publish something that undermines their entire philosophical view. So, again, it's like going to the Catholics and saying, will you publish my, brutally harsh clinical evolution theory? When I started to them, the burden of proof is on them. When I stated to them, the burden of proof is on them. Yes. I mean, obviously they don't want to prove they can't prove their theories. So again, that's this, and they won't admit that they're weak theories. I mean, you have to argue the argument, so to speak, and they won't do it. So they expect the argument to be already endorsed by some authority, and then they'll pay attention. When that's impossible. If I already have the endorsement of the authority, I don't need them to argue it anymore. I don't need to argue it anymore. Let's see. Completely agree with you with what you were saying about gravity having an acceleration that you can't feel because it's affecting all the microscopic matter at the same time. Yes, I mean, it's an interesting observation. I don't know how long ago I came to it, but it was a huge realization in a way just to think about it and say, yes, this is the huge difference between one force application and another force's application. Is that, yeah, if it actually is moving my atoms and not me, right? If gravity is actually a nuclear force and it's moving electrons and protons and it really doesn't have anything to do with me, well then, yeah, how can me feel it? Because, yeah, all my electrons are all getting pushed by the same force. They're all moving the same way, so I can't notice the difference. But, yeah, if somebody kicks me in the ass, yeah, I'm going to notice I have been affected, so I can't notice gravity affecting me. Again, it's the whole thing. Like I said, all we feel is the earth pushing us back. That's what we feel. We never feel us pushing into the earth. Yeah, no, I'm just saying it's been my experience. They will not tolerate the conversation. They just won't do it. They'll find some way to insult you. They'll provoke they'll accelerate the ad hominem perceptions and, call each other names, and they'll do everything they can to get out of the conversation by having it degrade into some sort of name-calling match. But they will not allow the subject to be explored, step by step. Axiom by axiom, argument by argument. I'll never get an answer to the question. I'll never get a scientist to admit, something as simple as the Eddington experiment. And they'll never say, yes, they should have duplicated the experiment. It should have been done by now. 100 years later, huge giant advances in technology, yes, they should have redone the Eddington experiment to confirm the results. And you can't get them to admit something that simple. It's just a world of fanatics. That's unfortunately. Ignorant, frankly, fanatics. I mean, these are all people who, they didn't do any research, again, so, they really don't understand how thin the evidence for mv squared was when it was accepted by physics. I mean, the evidence was insanely underdeveloped. All right. It kind of turns Einstein's whole ideal on its head of free falling in gravity being the inertial frame. No, you just can't feel it. Exactly. You are not the one not being affected by a force. Exactly. And it's just kind of, like I said, it doesn't matter how fast gravity pushes you, you're not going to feel it. I mean, it's that perfect. So, no matter what acceleration it's imposing on you, you're not going to feel it. So it could push you insanely hard, and you'd be like, nothing's happening here. Oh, I just went 1,000,000 miles an hour? Well, could have fooled me. So unfortunately, Einstein just didn't do the. Like I said, it's just a convenient, that Einstein got away with this bent fabric thing, right? I mean, that was the analogy used, was the bent fabric, in the early days, and it's this stupid two-dimensional, bullshit that depends on gravity to even make any sense, right? I mean, making the bent fabric the well only works if there's gravity to push things into the well. So in a sense, it's using gravity to explain gravity, which is really bogus. And if you turn it into the three-dimensional monster, the bent geodesic with the 3 dimensions, it's just a vacuum cleaner. You're just saying that somehow in the center of the earth there's something vacuuming a bunch of stuff out of the universe, and you're catching everything in the flow of the stuff. And I mean, it just doesn't make any sense in some, And so there's no energy here. I mean, there's no rational energy, right? What's running the vacuum cleaner? Where's the exhaust from the vacuum cleaner? So it just doesn't make, there's no continuity. There's no force in the real universe. The bent geodesic is itself its own self-contained mechanism. And it just takes it out of the physical reality. It disconnects it entirely from all the other physics in the universe. So, I mean, it's a huge, giant, creepy disconnect to all the other kinematics that cause motion in the universe. So, to me, it's just so obvious that it's obvious gravity is a force. It's it's stuff. And all you have to explain is how does more stuff go into the earth than come out of the earth? And like I said, I think I have explained how that could happen. I mean, in a sense, I was just thinking how you could sort of say it's sort of like a bending of space, in the sense that if you think about the force and you think about the idea of the force slowing down, and that there's always this difference between the action moving something and the reaction. There's always a lag in there in the real universe, like there's space in between objects. And what you're really doing when you move something is you're compressing the space it's moving into. And you're really using that compression in space as a kind of absorption of energy, because it's creating more energy for the outside, but it's less energy on the inside. Or vice versa, you could look at it. But, and that's how you've subtracted the energy from the outside space, is by consolidating objects on the, consolidating force on the inside. So by moving force closer together on the inside, you've obviously sort of taken some of the energy out of the outside. If I could compress force, if there was photons and I could compress the ones here, effectively I've stretched the ones out here, in a sense. I've stretched the space. Well, the simple point is that, gravity obviously doesn't care about time, but gravity is decided, okay? It functions. Time is what makes it relevant. It's a time dependent. It happens per a unit of time, is this transition of things moving from one side of the earth to the other side of the earth. And it's the amount of time, okay, it's a piece of time being consumed, is essentially the fact that you've slowed something down is the same as taking energy out of it. It's more complicated than 4 words, I guess, is all I'm saying. Let's see. So I guess that's still... I'm caught up. All right. Let's see. Well, I guess we can see how many people are here, just for curiosity's sake. 13. Yeah. Well, it's better than 9, but it's still just a little too few. I just think that is a powerful argument. It says right on the gravity thing, 9.8 meters per second. And people are arguing that it's per meter or per foot or per inch. And that's almost ironically funny, right? It says right on it, 9.8 meters per second. Per an amount of time, you get the 9.8. You don't get the 9.8 per something else. You get it per a unit of time. It pours into the bottle by time, fills the volume. And so if you don't have enough time, you don't get the volume. You don't get the stuff. And distance, it's just, who cares? It's not about how much distance you did in the space. It's about how much time you were in the space will decide how much stuff you got. It's clearly saying it. It's just saying it loud and clear. And then all their other equations all have this stupid distance in it. Like it's the distance thing, when all of them just need to be changed to put the time thing. MGT, not MGH. It's not about how high it goes in the gravity. It's not about how high it fell in the gravity, how far it fell. It's about how long did it fall. How long did you free fall? That will decide how much energy you collected. That's it. The end. All right, 2-minute warning or so, or such, or something like that. Well, a change of pace anyway. I haven't done some other, one of these more abstract subjects in a while. You have a pretty common sense take on time. I wish it was common sense, right? I mean, it's really not, frankly, common. It's simple. You could argue that. Unaggrandized, ungilded, crude. You could even call it a crude take on time. I'm pretty crude about it. It is what it obviously is, okay? It isn't what there's nothing unobvious about time. It's obvious what it's doing, right? It's just fucking obvious. It takes time for my neurons to fire. It takes time for the sentences to be composed. It takes time for me to speak them. It all just takes goddamn time because everything's not happening instantaneously. So, yes, it takes time for everything to happen. Yes, it's that simple, okay? But unfortunately, it's not common. Where there are moments and corresponding moments elsewhere. What? Where there are moments and corresponding moments elsewhere. I'm just saying you can't change the facts of the... Again, it's probably just more about the idea that the universe is just what it appears to be. There's stuff here, and then there's stuff over here, and then there's stuff over here, and there's stuff over here. And it takes time for photons to get from one thing to another, and that just tells you, okay, I can sort of understand the distance thing. I can see the distance thing because of these photons. I can compare photons from here, and I can compare photons from here, and my brain can figure out some size differences too to make it three-dimensional. But I can understand, I can model the 3 dimensions, and it's perfectly understandable that that's what things are in, 3 dimensions. So, I mean, obviously, the 3 dimensions are in the same universe, and whatever is happening between them is all kind of organized by this time thing, that moment to moment to moment to moment, things will change, and things will be moving at, speeds, and it will take exact amount of time for things to, So, yeah, there's just one time now. That's it. It's now then, but you know what I mean. It was now while it was now. I mean, I've sort of made that argument, that there's, really, it's really difficult, to do this, what is there, because really all there is the future, because the present is always the past, in a way. So anyway, but yeah, there's just no reason to think it's something other than just a function. It's just a function. It's not a dimension. It's not a place. It's not something abstract. It's something just elemental to one fact. There's no instantaneous. There's no, everything takes time to happen. Nothing moves timelessly. I guess that's what you could argue. I don't know something, but I'm just saying that's the fact. It just happens that the universe is running slower than as fast as possible, or something. Whatever that would be. Whatever. It's not an instantaneous verse. I mean, it's one of those paradoxical infinity things, right? Because it doesn't matter how slow it is. It just has to be any amount of slow. So, I mean, it can be an infinitely small amount of slowness, and it would seem to us to be the same amount. You know what I mean? We couldn't tell the difference. I mean, whether the universe was running a very fast clock or a very slow clock, it's just the fact that it is a clock. You would say there is a sort of global universal time. Global doesn't even work, right? There's a universal time. Just fuck the global part. as Newton would say. Yeah, Newton believed in 3 dimensions and time was a function, so that's pretty much the truth. It's surprising to me that people say otherwise. How else could light travel the same speed anywhere? Exactly. We measure it being very consistent. The whole thing seems to work very consistently. There's no experiments that really demonstrate any inconsistency. So, I mean, why the fuck are we assuming inconsistency when it all seems to work so well? And, all they're doing is throwing up, the fact that atomic clocks go a little wacky, depending on what environment they're in. And, that is just so not very compelling evidence. I mean, it seems weird that you actually have to argue that it's not a miraculous assertion that clocks break. Ooh, that's miraculous. Oh, I don't like name dropping, but whatever. Says there are Carlo Rovelli says there is no now on Alpha Centauri. I literally have no idea what he means. Yeah, well, I guess he's saying until we get there, there is no Alpha Centauri either. So he probably says there's no Alpha Centauri until we look for it. I don't know. It is just so wacky. It has to wait until we decide what frame we're in and what frame Alpha Centauri in, and then we can tell Alpha Centauri when it can have now, because it can't have its now until we have approved when it says now. It's just. Look, when Einstein broke simultaneous events, when he actually tried to make some coherent argument that simultaneous events are not simultaneous because I'm closer to one than the other, I mean, how could anybody say that made any sense? I just don't get how that could be an interesting statement by anybody. How could somebody say, yes, that makes perfectly good sense. I've changed reality by moving closer to one object than the other. No, I didn't change anything. What the fuck did I change? I mean, you're just like, no, how could somebody believe that? Like, there's no front of the elephant if I'm looking at the back of the elephant? I mean, I don't even know how you make that make any sense. I mean, when we know we're so, we're so perceptually bound. See, yeah, this is one of those perspective things where, it really I guess I get more of a feel for just how fucked up our senses are, our perception, because we're seeing through a pupil and all this other crap and blah, 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 and the real photons aren't doing what the little tiny number of photons that go through our pupil are doing. I mean, the real photons are kind of just going in straight lines right into us. And we're seeing a very weird perception of reality because we're forcing the only photons we're going to register as existing are the ones that went into our eye in these bent, crooked paths. But anyway, just as a painter, it's very interesting, when you're painting, if you turn your painting at different angles, and you can see it changes so much, just tilting a little bit. And, it just makes it so clear how it's so much a subject to your angle of how you're viewing something, and some of the great artists actually did this. They put satire into their painting. So, like, say they were painting the king, and they would paint his portrait, and then at an angle, though, if you looked at it at just the right angle, they'd paint moron or something. It would say moron or something across the painting. You could see it. So they were putting like invisible messages in the painting that you could only see from certain angles. So, I mean, the fact that our brain is so easy to trick just sort of gives away this whole idea that why are we talking about what we perceive? Why is that relevant? We're really talking about making it a model and just getting our perception out of the question. We don't want our perception to distort the model. Well, I wouldn't call it just a measure of activity. You're just saying that anything called an action takes time. So the fastest thing in the universe has to take time to do something. So there's no such thing as any activity in the sense that all the activities are already time dependent. So it's not a measure of anything. I mean, time isn't measuring. Time isn't doing anything. It's just a byproduct of slowness. So I don't know how else to say that, but that's all it is. I posted your shorter video explaining the argument regarding levers, the bowling ball and the train. Yeah, well, good. Some of my recent videos have gotten better and better, but yes, the argument, frankly, the argument I was making 2 years ago should be good enough. I mean, the lever is sort of, the argument should be over. I mean, levers clearly, by kinetic energy theory, create free energy. There's no doubt about it. You can put the 10-ton train going 5 miles an hour in one side, and you will get a 5-ton train going 10 miles out the other side. You will create free energy. All right, yes, it's a measure of activity. That's why there's no universal time. Well, fuck you. A measure of activity. What you're saying? Activity doesn't happen in real space in real time. You're saying everybody has their own time and they have their own place in the universe. And you have your own special little time. Ugh, fuck! What a pile of crap. I have to see what the hell this channel is. Let's see. I wish they would. Open a new tab. Yeah, let's try that. Well, that's interesting. Nothing. So it just opened the icon. Oh, thank you, YouTube. Very exciting. It opened the icon. Yeah, go fuck yourself. Anyway. Oh, I mean, really, well, who the fuck are you? What the fuck is this moron? No content, no nothing. It's just a troll. Oh, okay, got it. Little troll account. Fuck off. I mean, what nothing statements? Yes, it's a measure of activity. Little baby talk. I'll put him in a put whatever it is in a timeout. Useless tripe. I mean, there's just absolutely no evidence that over there is a different time than it is over here. I mean, they're just basically saying, "Oh, I can pretend it. If I make the other place far enough away, I'll pretend that time over there is different than time over here." I mean, it's just so fucking stupid. Is it possible there is a universal time? I don't even understand, why should I believe anything else? Why should I believe there's no now on Mars right now? Right now, there's a now on Mars. What's the difference if I go 500 million more miles away? How far away do I have to go before all this now thing stops being a now? I mean, it's just too silly. I mean, right now, there's a piece of dust on Mars, and it's sitting there, and the wind's blowing, and the little piece of dust is going to go boop. Right now, it's going to happen. And if I had a microscope, a telescope, and I could actually see the little piece of dust, it would actually take the speed of light. I'd have to wait to the 8 minutes or whatever the fuck it is for me to see the little speck of dust fall. And I can understand that. I mean, we can look into space and we can see yesterday, and we can see the day before yesterday, and we can see the day before yesterday. We can see back in time. I mean, all those events happened on a specific day at a specific time. I mean, why are you? Anyway, in addition, also have experience of time. An experience of time. I don't. What the fuck? I don't know what experience of time is. I mean, clearly my experience with time is to realize just how slow I function. Okay, and just, wow, it's incredible when you think about just how slow everything's happening. Your brain taking forever to come up with these ideas and thoughts when you think how fast the rest of the universe is moving. All the other stuff is moving so goddamn fast by comparison to how slow my brain pops an idea into my head. Where microscopic matter bits change more slowly under certain conditions. I don't even know what you're talking about. Change. I have no idea what the fuck you're talking about. A photon goes slower, an electron moves slower, a proton moves for no reason, and just because there's some warpy time thing. I don't know what you're talking about. I can't imagine it. I can't do anything with it. I can't make that into physics. And I can't even understand it as a religion. I can't understand why you think there's some reason I should believe that the atoms moving inside of here aren't moving just like the atoms inside of me, and that the temperatures are the same, and that this, and I mean, why would I think there's some time difference? Alright, anyway, so traveling faster may mean your matter bits react and update in the universe slowly compared to the resting matter. Well, this update crap is another lie. There's no update. There's no, I don't think you have to do that. I mean, you can. You can turn the universe into something that's just ticking, little, and everything just moves one tiny notch. A photon just moves one notch per tick of time. But why would there be any inconsistencies again? Why was there any need to warp it or bend it or twist it? Why wouldn't time be dead consistent? Just like checkerboard spaces, click, 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 click. You have to jump the spaces. You can't jump all the spaces. You have to go through each space. So traveling faster may mean your matter bits react and update in the universe slowly compared to resting matter. Well, I would think the opposite would happen, because obviously you're creating more interactions with the universe. So this whole idea that you're going to slow something down when you're creating the highest energy circumstance you could possibly create. To make matter move that fast, you have to supply an incredible amount of energy. I mean, trying to think of a way to analogize it, but because you're really just changing the bias on something, right? You're changing something everything's in a pressurized condition, and so obviously the drag argument comes into effect. You're for pushing from one side an electron, and you're pushing it into a field of energy very fast. You have to concede it's got a ton of energy. It's coming the opposite way now. So, it's going to be really hard to figure out how you could actually acquire these huge biases in your direction without having a huge bias in the energy pushing you. I mean, you have to have much more energy. The closeness of like a photon, if you're going to go by frequency, you have to have something that has a minute frequency between the bits, a huge high energy, gamma ray or something, to be able to overcome the fact that you're condensing all of the energy in front of you. So as you're moving, you're plowing into a bunch of force you would never hit, that wouldn't hit you for days later, till days later, and you're plowing into it now instead of days from now. So you're compounding days worth of energy into one moment, and that's a lot to overcome. But, just the idea of moving an atom. So once you can show you can actually start moving material objects any kind of speed close to anything really, really fast, then you can start having conversations about what happens to matter. But, I mean, we can't do anything like that. Does distance contribute to an object's age? I don't even know what that means. You have to travel the distance, and it takes time to travel the distance. So obviously you're going to age while you're traveling the distance. You know, I mean, you know, the photons that left some galaxy 13 billion light years ago and have been traveling for 13 billion light years, they're really old photons. I mean, they've gotten really old. You just can't outrun the rest of the universe. There's no, you can't outrun time. You can't, you know. You can't go into a special room and then time passes outside and then you walk out of the room and now you're at the future. And you can't do the opposite. You can't, you know, somehow, you know, undo the time that's taken place and somehow go backwards. You know, there's no fucking way you can do any of this shit. So I don't even know what you mean by perception. I don't know. So if somebody's further away from me, they don't look older to me. So I'm not getting the whole perception thing. I'm just arguing, look, if you want to travel to the future, you do it by cryogenically freezing yourself, stopping yourself from living so you can wake up again in the future. That's the only way you're going to do it. And every other effort is going to make you older, not younger. Okay, so if you try to go to the future by going fast, what I bet will happen is you will burn up and, you know, you're not going to physically survive it, because it's not going to be a less energetic adventure. It's going to be a more energetic adventure. You're going to be, you know, whatever, oxidized. I mean, you're going to be ionized and then oxidized. You're not going to be frozen. Alright, so I guess it's time to go. So anyway, thank you and such, I suppose. I mean, you could all just say, oh yeah, you're right, there's no reason to believe all this crap, because they really haven't proven anything, except clocks break. Let's see, it'd only be less energetic if motion meant you were interacting with the universe less. Yes, well, I'm just saying that it's just, I mean, that's like saying 2 + 2 = 7. I mean, that just can't make any sense, to think that motion means less. More motion, less energy. That doesn't make any sense. So there'd be no reason to think that. Alright, anyway. Yeah, that's just... Nope. Alright, so till the next time, and such and so forth, and whatnot.